the last conic we're going to talk about is our hyperbolas. A hyperbola is the set of all points x, y. The difference of whose distances from two distinct fixed points, called our foci, is a positive constant. So our hyperbolas look like this, or you could have them going vertically. And the axis that goes through them is called our transverse axis. You would have similar over here, but it would be a vertical transverse axis. You have your center, your vertices, right, like you would like two parabolas there, and each of those has a focus, so we have our two foci. And basically what we're saying with this down here is if I have a point on either branch, the distance to this foci, which is d1, distance to that foci, if I subtract them, so d2 minus d1, that is going to stay constant no matter what point I'm looking at. So that is a constant value. All right, let's actually get into the nitty-gritty of some of these. So, with our horizontal transverse axis, let's start there. You will have your center, which, just like it's been the whole time, is HK. You will have your vertices that are going to be a distance of A in either direction from the center. If you have a vertical transverse axis, which I'm not going to draw the axis this time just to give you a little clearer view of everything, then that distance above and below the center would be A still, and these are my vertices. Right, and I'm going to focus on this one now, getting all of our information over here. So vertices are there. You have going distance of B, in this case above and below. Those don't really necessarily have a name. You could maybe call them your co-vertices, but we are not as focused on them because we are going to kind of draw a box that uses those vertices and those points, if you wanted to call them again co-vertices, to help draw my hyperbola. Because through the corners of that rectangle and through the center, I can draw those dotted lines. Those are called my asymptotes. And my branches kind of follow along those asymptotes. Coming out from the center to your foci, by the way, should be C, just like it was earlier. So here, I'm going to draw this one without my asymptotes. So here's my branches. They should be mirror each other. And then in line with your vertices and your center, you have your foci. That distance from the center to the foci is C. Remembering B again went out to the other side. C squared is going to be equal to A squared plus B squared for these. For your horizontal transverse axis, for my branches that are going to the left and to the right, my formula is x minus h squared over a squared minus, so that's a big Q that you're doing hyperbolas, you're a minus there, y minus k squared over b squared equals 1. If I have a vertical transverse axis, then it's going to be y minus k squared over a squared minus x minus h squared over b squared equals 1. So for both of them, they need to be minus. The a for these is not the greatest number. It simply tells you if a is under my y, then I'm going to go from the center vertically to my vertices and foci. If a is under my x, then I'll be going horizontally. Let's go ahead and look at just some formulas to keep track of everything. So asymptotes, and really we're going to do everything else on here too. So this is for a horizontal transverse axis. So again, they're going like this. Your vertices are going to be at h plus or minus a, comma k, because from your center you're going a distance of a left and right to get to your vertices. Your foci, you're still going from your center left or right, so it's going to be h plus or minus c, k. And then for your asymptotes, it's going to be a formula because those are lines. I'm actually going to look back at this previous slide. If I look at this first one where I drew my asymptotes, the slope of this line here, rise over run, would be b over a. And same here, b over a. This one would be negative. So because I'm going to have b over a for both of those, positive or negative, that will come into play for my horizontal asymptotes. So it's going to be y equals, and then it's k, so that I can get whatever the y value of my center is, plus or minus b over a times x minus h. And that will give me the equation of my asymptotes. If I have a vertical transverse axis, so my branches look like this for my hyperbola. The vertices, so here's my center, I'm going above and below that, so my h is not changing. For my k, I'm doing plus or minus a. For my foci, again, staying in line with that center and going above and below it, so it's going to be h and then k plus or minus c. And for your asymptotes, again, we'll look at the previous slide for just a second. If I drew my line through here, my slope is a over b, because that's how far I'd be coming over. So in this case, it's a over b, rise over run. So y equals k plus or minus a over b times x minus h. Remembering again that your center is hk, and then a, b, and c have the relationship just like Pythagorean theorem. All right, let's look at a couple examples. So we're going to draw the hyperbola and write the standard form given this information. So first thing I need to do is start working on my graph. All right, so I have vertices at 0, 2. And at 4, 2. So if those are my vertices, then I know that right in the middle of those should be my center. My center, since it's right between those, I don't know why it's not letting me write up there, sorry about that, should be at 2, 2. So I can go ahead and start, well, I need to figure out if it's going, since it's going, towards the right and left, that's a horizontal axis, transverse axis, so I'm going to have x minus h squared over a squared minus y minus k squared over b squared equals 1. So I can go ahead and plug in my h and my k with just what I've done so far. Since my vertices are just 2 away, that means I know that A is 2. So this is going to be 4. My foci are at -1, 2, and 5, 2. So those are 3 away from my center. So to find B, remember c squared equals a squared plus b squared. So to find B, that's going to be the square root of 9 minus 4. So I'm looking at radical 5. So over here, b squared would be 5. Okay, so there's my equation. I do need to finish off my graph. Since b is radical 5, I can come up about that distance. Okay, I had to move my graph down here, but I can come up about a distance of radical 5 and put my b's go down about a distance of radical 5. And then I can use those dots from the B and with the A to make this rectangle. That way I know where to draw my asymptotes through. And then when I draw my branches, I can kind of trace out my branches. I cannot do lighter or darker on here, so I would just try to make sure your asymptotes in this box don't need to be very heavy. Your vertices, your foci, your branches do. Draw the hyperbola and find the center, vertices, foci, and asymptotes. So the first thing we need to do is get this set up in the correct form. So divide everything by 16. So I'm going to have x squared over 4 minus y squared over 16 equals 1. So looking at that, a should be 2 and b should be 4, which means doing Pythagorean theorems, or c squared equals a squared plus b squared, that c should be 2 radical 5. So when I go to draw my hyperbola, I'm starting at 0, 0 for my center. The x comes first, so I'm going left and right 2 for my vertices. I'm going up from that and down from that 4, and those are just like your co-vertices to help draw this little rectangle. And you need the rectangles so that you can draw your asymptotes. Once you have your asymptotes, you can really draw your branches. And don't forget your foci, which should be 2 radical 5 in either direction from the center. For points, my center is at 0, 0. My vertices are at, so I'll go left and right of my center at 2, 0 and -2, 0. My foci are at plus or minus 2 radical 5, 0. And my asymptotes are y equals k, which is 0, plus or minus, and in this case it should be b over a, so 4 over 2, which is 2, times x minus h, so really just x, so plus or minus 2x. So that gives me both lines there. On the last one, you need to go ahead and do your completing the square to get this set up in the correct format. I want you to try that on your own. Once I get it like this, I do need the positive one to come first, so I can reorder that in the correct format, and that shows me that since my y is first, that this is actually going to have a vertical transverse axis. So this is my equation. So looking at that, I can tell that a is 2, b is radical 3, and c would be radical 7. I can use all of that to get my graph, which you should do, and to list out my center, vertices, and foci, and then I'll show you how to do the asymptotes one. Since you have a vertical transverse axis, when you do this, you're going to have k, which was 0, plus or minus b over a times x minus h for your asymptotes.